So I do them from scratch every year too. Mm. Okay, so I'm trying not to give you too much because these can be a little overwhelming. Um, anyway, so what you do again depends upon what you are looking at, and I wouldn't get into the habit of trying to do the same thing over and over again. That might be successful sometimes, but you're going to get to a problem where that procedure that you enjoy might not work as well. In general, converting everything to sine and cosine, that tends to be a good idea most of the time, but there are exceptions. Here, no problem. So just converting the secant over cosecant. So when you divide by a fraction, you multiply the reciprocal, and both of these two now tangents. So then when you add the two tangents, you get two tangents. Okay, so 47, converting the right fraction into based on sines. And then I went ahead and multiplied sine on top and bottom, which converted what was on the right side to be equivalent to what was on the left side. Now, once you get to a problem like number 49, they're already sine and cosine. This is where it gets tricky. And I bet if you struggled with this, 49 probably was a challenge. When you're not sure what to do, if you have two fractions, probably getting a common denominator is a good idea. But I looked at that and it looked like if getting a common denominator was done here, that might make the problem more challenging. So I didn't try that at first. Instead, I used the conjugate with the denominator on the right side. Remember, conjugates are good because you'll convert with the 1 minus sine times 1 plus sine, you'll get a 1 minus sine squared, which is a Pythagorean identity, which is a good thing. So I tried that first because I knew that 1 minus sine times 1 plus sine is going to get 1 minus sine squared, which is cosine squared. And again, I could think ahead, so I kind of thought, well, wait, that'll cancel the cosine on top. Let's see what happens. And that's exactly what happened. That canceled the cosine on top, which leaves us with two fractions that have a cosine denominator, much easier because they're already a common denominator. And then when you combine these two, the signs cancel out, and there you go. Right? Now, maybe if you got a common denominator here first, that could have worked out. I didn't even try it because this other choice seemed to work better. And again, I chose it because I wanted to avoid getting a common denominator with the cosine and the 1 minus sine. That to me was going to be a little more challenging. Okay, so I reserve that for the second attempt. Instead, I chose to multiply conjugate based upon the 1 minus sine denominator because I knew that was going to convert to a 1 minus sine squared, which is a Pythagorean identity that becomes cosine squared, and that simplified that fraction. Now we can add the two fractions because they already have a common denominator at this point. Okay, and then 51, I converted to sine and cosine, and then on the right side, I multiplied top and bottom, and that got us something equivalent to the left side. Okay, now 53, I didn't see how it was avoidable over here to first convert to sine and cosine. And then I didn't square these binomials out, so I just left the 1 minus sine squared. And then on the bottom, since it's a common denominator, that's cosine squared. And then I just stopped right there and then looked at on the left side. Well, on the left side, if we want to equal where we got here on the right side, okay, it looks like we need the left side to be 1 minus sine squared, just like the right side. Okay, so that told me, well, let's go ahead and multiply top and bottom by 1 minus sine. That'll get us the 1 minus sine squared on the top as well. So that way both sides have the same numerator. And that got us a conjugate multiplied to the denominator, which becomes a 1 minus sine squared, which is cosine squared. Right? So notice this is tricky in a lot of ways. You know, we tend to kind of want to always square binomials. We tend to do things like that. But with trig, it's probably best to reserve that. So, and that way you can take advantage of seeing a little bit more efficient method of verifying the identity. Okay, and then this one was a little gnarly. All right, so number 55. I went ahead and converted the tan and cotangents, and then getting rid of the denominators in the bottom. So I multiplied top and bottom by cosine here and top and bottom by sine here. That simplifies that denominator. And then I looked at the denominators, and it looked like the only difference between the two denominators was they were inverse order. So I just factored out a -1 to make the left denominator the same as the right denominator. And now we got common denominators. And then this is where, if you got this far, you might have got stuck. Notice the top is a difference of 2 squares. One of the factors happens to be the same as the denominator. So there's a lot of different things going on, and factoring was another useful tool. Okay, and then this last one, which appears to have been rotated. So let me do that. This one didn't appear to be much of a challenge at first. So I went into it, I'm like, gnarly. There didn't appear to be any way of escaping after converting the sine and cosine of getting a common denominator. So unlike what I did up here for number 49, I didn't see any way of avoiding that. So I multiplied each fraction by the other denominator. And then when you get to the top, I did do the distributive property with the sine times 1 minus sine, because I noticed we might be able to get a sine squared cosine squared, which is 1. And after that, well, that's the same as one of the factors on the bottom of the fraction. And so that enables us to verify the identity, because 1 over cosine is the secant. Okay, and I'll just point out one other thing about that one. Another way you could structure that one, because a lot of times we just cancel terms loosey-goosey and get a little silly. So I'll point out another way to visualize what I just did there. So you could kind of think of it like this: 1 times that, right? So 1 over cosine is what's left over when you divide off the common factors.